Okay, a little bit different problem here. In this case, what we were given is the cosine of b is 4/5. All right, so we're given a trigonometric ratio to go along with cosine. And we're also given a side length there that a is going to be 10. So what I've done is just drawn kind of an arbitrary right triangle here, labeled my angles A, B, and C. Tend to go with C being the hypotenuse each time. So side length C is going to be across from angle C, and side length A is going to be across from angle A and B equivalent. All right, so in setting this up, I can go ahead and label that side length A is going to be 10. So fill that in. And then because we're told something about cosine of B, what I'm going to do is label things based on this angle B. So what I mean by that is the opposite is going to be side length B. The adjacent is going to be side length A, and the hypotenuse is going to be side length C. So as we get going on this, we are given cosine of B. Cosine of B is equal to 4/5. But from SohCahToa, we also know that we can represent cosine as adjacent over hypotenuse. So I'm going to represent it both ways. All right, first of all, adjacent over hypotenuse for cosine of B. We can say adjacent is 10 over the hypotenuse, which right now is just represented with C. Well, this has to equal this ratio, this trigonometric ratio of 4/5. So from there, we can kind of discount the cosine of B on the left-hand side and just focus on this equation that we've created. All right, so we can solve down this equation. 10 over C equals 4/5, and trying to find C on one side by itself. To do so, what I'm going to first do is get C out of the denominator by multiplying both sides by C. That'll isolate. We have 10 equals 4 times C/5. Now, I don't like having fractions, and many of you don't either. So let's go ahead and multiply both sides by 5. So in multiplying both sides by 5, that'll get rid of the fraction. 5 times 10 makes 50, equals 4 times C. And then to get C all by itself, we'll just divide both sides by 4. So here we have C is 12.5, 12.5. All right, the last thing we need to find on this is our side length B. All right, so to find this side length B, what we want to do is probably just use the Pythagorean theorem. So we can say a squared plus b squared equals c squared. So in our case, we know a is 10. We don't know what b is, so I'm going to leave that as b squared equals c squared, so 12.5 squared. Okay, so an equation that only has this one unknown. Let's go ahead and say 10 squared is going to be 100 plus b squared equals 156.25. Okay, next I'm going to make this into a power equation by moving the 100 to the right-hand side, isolating the b squared. So I'm subtracting 100 from each side, so that'll give us 56.25 on the right-hand side. To finish this up, we'll apply a square root to both sides to eliminate that square from the left-hand side. So that'll put b equals, well, the square root of 56.25 is exactly 7.5 units. All right, so now we found all three side lengths, and that was basically the goal on this. We don't need to find angle A or angle B. When we get to inverse functions, we'll be doing that. So good luck as you're setting these up and solving down.